I'm Damien Bloch. I'm a PhD student at the Institut d'Optique in Palaiseau. And right now I'm doing my third year of PhD in the group of Antoine Borez and Igor Ferrier.
Hello.
Salut.
Ça va? Comme d'hab. So my name is Britton Hofer. I am a second-year PhD student at the Laboratoire Charles Fabry. I like the experimental aspect where we work on pretty complex experiments, but we're still capable of doing almost everything ourselves. We do the electronics and write the code that runs the experiment, and we build the optical setups ourselves. And so that's, I think, super cool to be able to do that.
On peut commencer parce que Adrien et Yanis, pour le coup, si on les attend,
Hop. With a beam with a very long Rayleigh length to...
My name is Igor Ferrier-Barbu. Here I work as a chargé de recherche CNRS at Laboratoire Charles Fabry. I am part of a group that is the Quantum Optics group, and I lead a couple experiments.
I mean, the balance between the two beams, that's pretty good. Like you have to change it by like half a degree or a degree sometimes, but it's much more stable than before, I would say.
Interesting. This meeting has two purposes. So we have two teams that don't work in the same room every day, so they don't know exactly what each other is doing, but they work more or less on the same topic. So this way they get to discuss a little bit what each other is doing, and this means that, for instance, they will see, they have solved this technical problem that I don't have to solve myself. And it helps them a lot also to realize what they have done, because they have to prepare a little bit ahead of the meeting, like to think about what they're going to present. And this helps them kind of summarize what happened in the week, why did they do it, how did it turn, etc.
The temperature on the table was not so stable, I don't know why, but it was ours.
Okay.
A lot of jumps.
So after the group meeting, typically now every team goes back on their experiments. And what we have to do now is to get the experiment started. This might take a bit of time. The experiment is a bit like an old car that you need to tweak a bit every time before you get it running. And so typically each morning we spend about half an hour or 1 hour to re-optimize everything, realign the mirrors that moved a bit, such that we can take data or do measurements for the rest of the day. On the good days, when the experiment is running well, this can be done in half an hour or less. Sometimes we go down in the lab and just everything is broken, nothing works, and we might spend the day finding what the issue is and fixing it.
The really broad way of describing the experiment is saying that it's a cold atom experiment. So these types of experiments, you choose an atomic species, and using laser light you can cool the atoms down to really low temperatures, which allows us to then study the kind of the building blocks of matter, of the light-matter interaction, for example, also. We build our system that we want to study atom by atom, and we look at then the interactions between the atoms or the light-matter interaction. On our experiment specifically, that's what we do.
The basic principle is to trap individual atoms in optical tweezers. You use a mechanism that allows you to trap one and only one atom in an optical tweezer. And now it's a field that's growing very fast, based on techniques that people have developed to actually trap many of them, to have many optical tweezers in parallel. so that you can have many atoms close to each other that interact. And so you build like this in the experiment a system that then you can do experiments on.
Lunchtime.
Yes. Ouais, la manip elle tourne, ouais.
So usually around 11:30 or 12, we all gather to go to lunch at the same place. It's about a 10-minute walk from the lab. It's the cafeteria of the Polytechnic school where we go to have lunch every day. It often happens that people start to talk about work. This is something that we all have in common, of course. On other days, people are a bit bored about work and they don't want to talk about it, so sometimes we talk about what we did on our weekend, what are our next plans for our next vacations, or anything in the last movie that we saw, or stuff like that.
So after we have lunch, we usually have a coffee break, and usually during the coffee break we don't talk much about work. We work a lot, and so we see each other a lot, and we thankfully get along pretty well. So yeah, it's a kind of a moment to think about something else, and the PIs we talk about really random things also with them. Like it's not we don't feel a huge hierarchy, or like there's no huge difference.
But they don't tell you which glass is water and which glass is wine. And the first I took, it was not water. I don't know what it was.
So I went down to my office to prepare slides for my habilitation. So this habilitation is something special. It's once in a career, but in general, preparing slides is a big part of our job, and it's quite an important part in order to communicate our results. It's one of the ways that we have to communicate our work. We have articles, papers that we publish in journals, but there is another way, which is conferences. So we present our work in conferences, and that's very important to be aware of what other people are working on.
On n'avait jamais fait beaucoup de mesures avec le probe perpendiculaire. Donc ça peut valoir le coup de faire ça.
Yes. Ouais, on peut essayer ça aujourd'hui et on regarde ce que ça
donne. We're in a period now where we're taking a lot of data. So right now the data that we're taking is actually the first experiments that we're doing to see that we have a collective effect when we have atoms that are at a certain distance from each other, and we send light on it, and we see the atoms respond in a different way if you were to compare to a single atom.
Comment la fréquence elle bouge en fonction du spacing?
Oui, on peut faire ça.
Parce que la dernière fois, si ça avait marché, est-ce que ça vaut vraiment le coup de le refaire?
Bah, je sais pas. Après là, la température est un peu plus stable quand même.
Lately, we've been mostly working on the computer when we are running the experiment. This was not always the case. I was the first PhD student on this experiment, so I had to start building the setup. When I started my PhD, the room was almost empty. I think there were maybe just one optical table in the middle of the room and with nothing on it. Very soon, after a couple months, we were joined by other people like Breton and other interns. So yes, we had to really build it ourselves, every piece, align it very accurately on the table. There are probably hundreds of mirrors, and do that for every single mirror in the room.
Okay. So the idea is to discuss a bit what Yanis has been to think of. The results that you've had with the optical block equations, even though it's not yet finished.
Yes, sure. But maybe we could discuss about noise, which is the
Yes.
main issue, let's say.
We have bought and installed a new laser, and this laser has to be quite stable. So what we performed in the experiment is one way to measure the frequency noise, if you want, of the lasers. The correlation function, which is integrated 1/2t, integral from -t to +t. The guy who did the measurements and tried to understand what was going on is Yanis, so he's an intern, Masters 2 intern. And so in his case, this was one way that he had a project that was important to us, but that he could do on his own without having to learn how the whole setup works before being useful. From the laser, from the error signal.
Ah, okay.
But actually, at
So
least
why don't we do that?
Maybe we should have a look at what they did.
So it's pretty common practice to discuss about what we're doing right now, or what we're doing at the moment on whiteboards. Sometimes also we'll have questions, and the PIs will then kind of improvise a quick course on phase noise or what have you.
Some dBs more, and it does a completely different behavior. So
Whiteboard, it's actually a very crucial piece of equipment that we use in the lab. There is one or two whiteboards in every room in the lab, and you're always covered with scribbles, schematics, and formulas. We would not be able to do our job without communicating to others by writing what we do.
average over 100 realizations.
Ce qui était intéressant, c'est qu'il montre, Sylvain, que la grandeur importante, c'est S de F sur F, apparemment.
S de F
Pas S de F sur F.
sur F.
Non, sur F.
Sur F. Ouais. C'est quoi F? C'est 0?
La fréquence de la... justement, je sais pas. C'est la fréquence de la transition.
One big part that you did not see is actually now becoming a big part of our work is to try to hire people. Because we see the team, but you have to build the team. And this actually uses a lot of our attention, like to hire students, to hire postdocs and interns, and trying to get them to work together, etc. There is quite a bit of work to try to hire students, make sure that they will be happy working with us, etc.
If we can get the experiment running during the night, we have twice as much data to analyze. And the experiment is set up so that we can monitor it, we can leave it running when we leave the lab, and then sometime we can remotely from home check that it is working as expected. This is actually something that can be nice, like you can set up the experiment and then every now and then you check that everything is behaving as it should. This is also sometimes a bit an issue because that means that it's hard to disconnect when you go home. If you still need to check the experiment is running, then you don't have a clean cut and you're still a bit working late.
When you're doing your PhD, you're learning how to become a researcher, but a lot of the researchers' work is to transmit their knowledge. When we go to conferences, we get to present our results, which is very motivating for us because we then also get to have fruitful discussions with researchers from around the world, which I think is very important for the work that we do. We were actually the first to trap single atom of dysprosium in optical tweezers. It was a kind of a eureka moment, I guess. We were proud that we had gotten this result and that people were then motivated because of our experiment.